Okay, so today's date is the 14th of July 2026. This is going to MMUKO OS. So MMUKO OS is spelled M for Mike, M for Mike, K for Kilo, uh, 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 M for Mike, M for Mike, Q for Umbrella, K for Kilo, O for Oscar, opera system. The human was first human right constitutional opera system. Okay, I'm gonna show you how it works, and I'm gonna show you how to use it. But this is MicroOS, so I'm gonna show you how it works now. I'm gonna show you how it works. Uh, 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 okay, let me get up. So this is the open access MicroOS. So let me just try to find it. Okay. So this is here. So you can see my screen, guys. So first of all, this is OBI ELF. OBNXS executable and linkable file format. Workbench developed by OBNXS. This is a OBL. This is a executable linkable file format. I'm gonna go through repository and show you how it works. First, so this is a OBL. I'm not gonna install it. Okay, let me install actually. So this is a OBL. This is the repository for it. This is basically using bytecode. So it's a if you look at the docs specification, docs bytecode, formal spec. This is formal spec. This is Madrid computational. So this is the OBL authentication, but it's linked to MicroOS. So MicroOS has two type of linkers, two types of file formats. Executable then linkable, or executable and linkable. Because basically, executable and then linkable is different from execute linkable then executable. Because link implies link then execute are stages of steps, but there are two ways to process files. So a file format has text files, markdown files, code files, but you have to ensure that this is a basically ELF system lookup systems for allocation things that are allocated like basically a simple ELF system uses in this kind of version uses a bytecode. So how this ELF system all work is you have a bytecode. So let me explain it in layman's terms. So layman's terms, this is what you have. So you have four stages. Four stages. You're gonna have tokenization. Uh, tokenize that when you are collecting the lexeme, taking raw becoming strings, characters, strings to lexemes, which are lexical analyzer strings or tokens. Lexemes. So tokens becomes lexemes, or raw strings, not tokens. Yeah, it becomes tokens. When we are lexical analyzer, which each lexeme is a token, or an operator, uh, based on the category, based on how it's done. Basically, it's a lexical analyzer. That's stage one of Rift. Stage two is parsing. So this is where you get the meaning, semantic meaning of the tokens in groups. In Rift, we use irregular expressions to do it. So this is stage two. So one thing is we got like stage one, stage two, parsing. You get stage three, which is AST. Now, the abstract string stage three is very important to understand that the abstract string stage three is used to model the grammar, used to create an abstract string of representation of the grammar. So if you have a specification, you can fit it to some kind of specification, because if it comes to programmable specification wise, which is more important, which is very important for the parser, because the parser gives the meaning, but the meaning across different systems needs verification, and that's what the actual finger to come from. This is brick switch three. So this is basically explained before, and so you get lexical analyzer, parser meaning or semantic meaning, actual switch tree or AST, which are the grammar that has red. like POSIX, POSIX, L, basically the production rule, how the grammar is produced, also known as the production rule in lexical analyzer in a parser issues three. So the parser has a production rule, which can be a kind of grammar, associated with that grammar, which is how the language is made up, which is what is the description of the association tree matters, because the root, left, root, right, right, root, left are all valid ways to backwards north form, back north form, BACKNAUR, back north form, or back no notation, post, the which is left, root, left, right. But some ways, some ATs are better optimized for computer compilers because the computer can process some kind of a token, some kind of order better than how we humans process it. Because we humans process it intuitively, won't say intuitively, but the computer processes it in a structured way. And this is structured for that data to be processed in a abstract history. Abstract history. So the AC grammar is the stage three. Now the bytecode. Now the bytecode of this ELF system is where this ELF system comes in. So the Vice code is what's important to understand. This one's gonna go in P. I'm gonna get in trouble because it's penis because he's gonna come out there and be naked. The bytecode of the fourth stage is where you get a executable bytecode for a target platform. Now, the bytecode for the target platform is stage four. So this is what Rift stage four it is. So you're gonna have a Rift basically. If Rift stands for Rift is the flexible data. Using a regular expression of that. So the idea is in this stage you are either linking then executing or executing. You are creating some kind of executable bytecode. Now this bytecode can be a library or a library, an assembly, disassemble artifacts, or the bytecode is the abstract representation for a platform. It is the representation for a platform. So think of the bytecode as what the bytecode as a abstract English phrase for a target platform. As you don't understand what I'm saying, but the idea of the bytecode is to execute across all platforms. Like it's a platform it's for target platform. It can be platform agnostic via the Rift philosophy. Standing for Rift is a flexible translator, which uses regular expressions to match target architecture to match the bytecode, because the bytecode is just a binary. It identifies file formats. So the bytecode use, like if you have MD file, what is the MD file doing? Is the bytecode as allocated as so. Let me show you what I'm saying. So I'm going to try to run my own code I've created. I'll show you some code here. So I'll show you some code here. So hopefully this doesn't come out running naked. Oh, this is not right. Okay, so this is the MMUKO Operating System. So this is for location. So this is for the bytecode. So the universal token is a triple term. So if you look at the segregation algorithm for OBI ELF, it's basically allows you to compile basically you can link any kind of file format to it because it allows you to load file formats up in real time. So like well, this is a kitchen for it. So this is OBF layout, OBF network assembler. So you get an assembler. So you need two things to use this. You need just Rust and Cargo, and you don't need an assembler. Normally, we can just link to it with Dash. But it's an ELF system, so it's loads of binary artifacts such as PNGs or but basically it works in a bytecode to identify binaries such as images because it can prefill the binaries based on the bytecode. So you can load up static. Don't come out naked, man. Okay, he's gone. So you can load up so this specification. So this document specifies the OBF universal part file architecture, defines testable semantic token part files, and policy system. But this is what I'm saying. So this is the token, a token in a byte file, in a token type value memory. Classical token is based on payload and memory. It's a final map of a byte. So it goes to byte infinity. A part is an index, ID, index total, file size, offset, uh, section, and the data. So this is the assembly of it. So this is how it works. So in layman's terms, I'm explaining that basically you get a bytecode. Let me just explain it here with the video. You get a bytecode. You know, you see, this is gonna be a very small file format, but it allows you to make this is a linkable data signal file format is really small. This is OB ELF. The ELF executable linkable. So we have executable linkable. We have two types. You have executable, then you have linkable, then executable. Because I'm coining executable linkable format as a then system. So executable then linkable. But this executable then linkable means you work on executables first. So you can link in more executables. You can keep linking executables into a final file format. But you have linkable then system. So I'm going to go to the specification. I'm gonna go through the system of how to use it. So this is MMUKO OS, basically the videos of MMUKO OS. So I spoke about the ELF system. Now let me go to the spec review. So this is what I used to verify the spec. Spec review. Uh, well, this is the bytecode. So this is how it works. So it works on gathering bytecode. So this is just the sample code. I can't remember where the full machine is. I lost the some of the work. But the parser AST, the bytecode, you can access policies here. But it's AST aware bytecode. It's AST aware bytecode. So that's the beauty of the OBL system. It's AST aware. So the artificial intelligence specification aware that's of the AST is translated into the bytecode. So you can have a platform algorithm bytecode. But this is the beauty of the AST aware architecture. So this is the security share from space validation. Define target. Okay, I'm looking to my own work, and I want you to, if you can read this, but this is the bytecode. This is Obinex's bytecode. This is the bytecode model for the AST. Now I'll show you these examples work. So I'm gonna go to these examples. I'm gonna show you this game working because this includes, see this image is Fruit Ninja, but this Fruit Ninja is literally running with OBF. It's running with the OBF. So this is it links all these artifacts, all these assets into the C compiler into C, because C understands that these are all binaries, because it's like an import. It's like importing an image. So it's like importing an image into a system, and the system is like the binaries are static files. So these are MD, PNGs, MD, PNGs, that are linkable into code bases, and that's what it's doing. So then you can run the example here. You can run the example here. Let me just run it myself actually. Okay, let me just go to the mix file. So so you can install cargo, install cargo, install OBF. This should work. If it fails, I failed it. OBF. OBF file package, OBF package, yeah. So this is OBF executor. We're using Rust, so you use cargo to install it. But this is cargo, it's sort of so OBF formats. Format OBF 32 winter 32-bit architecture and 64-bit architecture. This is the architecture system you can link to, but you can use it to use NASAM, that's file OBF. NASAM, network assembler, not recognized. If I NASAM OBI ELF net 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 NASAM. Let me get search NASAM. So this is OBI ELF basically. This is a NASAM. So this is nothing. You can net net file assembler. Okay, basically, you can it's here installed. I'm kind of doing part of it. So let me just write a make help. So this is make command. But all the office here in this directory. This is here. Can you see my screen? Yeah. So you can see my screen. So CD examples can't read me. Make OBS preview. So this is uh, okay. So this is make help. So okay, let me just make the image first. Let's start with making the image. So this is the image file. So this is the result of booting from MMUKO image dot MMUKO image dot the image file. You can load it to VBox. So if I write the image files is basically the it's like a another word ISO that's been created. This is called an image. So it's a system image. It's for booting into VBox. So like for the architecture. So for the architecture is built on. So this is the boot image. So this is the Riff Magic. This is meant to be Riff NSRB, but this is like a this is just AI stuff I think. But NX this means to be Rift, but RIFT because it's basically used to Rift is a flexible translator. But this is the file format. This is the magic file format. So it recognizes bandwidth. But it's not important in this system. I can always change this to the syntax for Rift because it's built by Rift, which is basically Rift, which is a system of stage bound execution. But you get a version one, you get a checksum, you get the sparse member active. This is basically a MMUKO B sequence. So phase one, phase two, active verify, and then CD verified and root success. So my system build this MMUKO was ring boot. So this is a ring boot philosophy. This is MMUKO. If you don't know what ring boot is, you will have to go and research that. So you're gonna write make help again. I'm gonna make boot direct. Uh, boot directory. Oh, this doesn't work. Okay, it does work. So it just doesn't do anything. So this runs this OB ELF equals 1. So OB ELF is not used. It's not linked to OB ELF, which is 0, which is fine. But you can write make verify make boot that makes the boot OB ELF equals 1. Okay, it uses OB ELF, it does boots. Okay, now let me write make VBox. This is make VBox. So this is a virtual box. It's power on the machine. So this is my virtual box. So this is the same message here. Uh, 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 Capture. Okay, let me just Control Shift plus. So this is phase one. Control Shift. Okay, you have clear the master version to capture the host on one side by the host can protect the phone. I don't have a right control, so I don't want to do it. So this is basically the ring boot. This is basically the OS booting. So this is a virtual box. You can see that it says here phase one sparse, phase two remember, phase two active, and phase two verify. This is basically the four stages of nuclear boot sequence. Quite beautiful actually. So I've got some examples here, but this is a human rights operating system. So the system has booted, and it does work as intended. But this is the code here. So like, let me show you the pseudocode. I believe you've seen pseudocode before, but Python. Let me show you the pseudocode. So cd examples, cd dot dot, cd pseudocode. cd pseudocode. Basically the pseudocode is here. Um, oh fuck hell, music is playing. Okay. So this is a example. So this is make help. Uh cd make, oh yeah. So this is make boot direct, make verify, make examples, open browser, Python /m http server. This is examples. So basically, this is the Trident boot. The H, yeah. This is a high one. So this is basically Trident boot. This is how you log in, but it's gonna be in code. So this is just observe. Every time we type uh, this is security. So you're not logged in. This is one example. So I'm just going to the MMUKO repository. This is make yeah. So this same thing. I have to sue these people. I wish I had enough money to sue people. You know, but it has to come with my pip. So this is the creator test virtual. Yeah, so you can load it to VirtualBox. But this is an operating system. So literally, I can start using it. I can't even log in. I don't know how to log in. You know, because I haven't got a proposal to do. So this is cargo build, cargo build here. This is a cargo in it. Yeah. So basically, I can write in any program. I feel comfortable writing all the programming languages because this is literally the foundation of the polygon. That polygon system was solved, so I can write in any language I want to do. But that's just it's a Python build image. So I feel stupid, but you know, I use AI to write some of it. Well, because but you know, it does. I did research. You know, if I did not do the research, I would not be building this kind of thing. So this is building. This is how it's built. So the output here. This the we see this here. So you know, dot slash spring boot. It needs virtual box. Please install virtual box. It is installed. And this is what I'm saying. It's not about this. So basically, all the commands are working. I think make OBI ELF preview. So this is OBI ELF preview. But see the OBI ELF. So this is the target of OBI ELF dot slash release build build release. This is a OBF package that has formats. OBF is a full. That has kind. Executable. That has name. MMUKO for input binary. So this would be things I'm linking in all the binaries I'm linking to all the system. But that's like this. So in the directory of it just installed it into the cargo module. But this is just the release, so it's not done well. But uh, it's like that. Okay, thank you for watching the video. Namdi. It's for myself, guys, not for you guys. So basically, or not basically, it's not basic. So the idea, I'm trying to build an ELF system. So I built an ELF system in Rust. I will go Isiki, which is linkable, then executable. There's two ELF systems. I built AI. I don't think it'll hold up in the real world. But we get MMUKO OS, MMUKO OS. So let me just compile MMUKO OS and show you how it works. So cd dot boot. Yeah, so go to boot here. I'll write make done. So dot slash MMUKO boot dot c etc. And we get all of this phase. So we get phase 0, phase 2, phase 3, phase 4, phase 5, phase 6, and phase 7. But this is a frame of reference southwest. So right now I'm facing southwest. Gravity medium. That's one. This is a G9 equals basically this is a 9 millimeters per second, 9.8 millimeters per second. This is lepton. This is a muon. This is a deep. This is basically a TOA. TAU. But this is a TOA. So this is a deep end. But you don't need the TOA or the TOA or TOA. TOA. What is the idea here? So you get a frame of reference, you get MMUKO, but this is just the I want to use this you can use it this MMUKO.tsc. This is the pseudocode up down switch on and you get you can take this file, this pseudocode file, but this is the Python notation MMUKO.py dash bytes 41248. So see, this is the code here. But this is just this is Mikobu. This is the distribute sequence. So you can this Mikobu is used for the to build the kernel, which uses this. So this is a Mikobu program. Hello from A, but it uses Mikobu. So these are the programs here. So this is the boot sequence, which uses the ELF system to boot. So the ELF system is OBI ELF, OBI ELF here. Let me just move OBI ELF to bin. Let me just move OBI ELF to bin and cd bin. Move OBI ELF. Move 3.3 release build 3 release OBI ELF dot slash release dot slash release. Let's check. I'm not using codecs anymore. Uh, but this is the binaries. Release. Remove the temp. packaging. Basically, see, the idea is that this is the debug information for bin, but I only need the binaries. Basically, I should be only clear if it's not doesn't work. But this is the ELF system, so this is the ELF system. So I'm trying to get the build. Yeah, so this is the ELF system. Yeah, the package system. This this is even in the docs. Oh, I fucked up. But it's not used bin OBF the RS. So this is the source code. Yeah, this is source code. Yeah. So I'm gonna try to package it here. I'm gonna leave this one here. I'm gonna leave this one here. I'm gonna leave here package. The debug here. Yeah. So this is debug. I don't need debug. I just need release examples. No examples here. Okay. So the fingerprint. I can always build it again from. Oh yeah. So basically, this is not the full build version. This is like literally being OBL to OBL. What do you want with me, man? I'm not gay. OBL release. So this is a release. Anybody that wants sex can have sex. I'm not having sex. You need to enjoy to have sex. It's better that way. So this is the bin. Okay. PDB. Okay. So basically, I've now this is OBL. That's just bin OBL. This is how it works. So basically, I'm not sure how this works. This is make. This is now cargo's now involved. Cargo build. There's nothing to build, so it just built an empty directory. But the bin for the OBL for repository debug bin OBL OBL OBL. It'll work. Okay, let me now publish this video. Because if I don't publish it myself, I'm not gonna do it. So this is the research here. So the idea was, you have an L system, OB ELF, and you have a linkable density system, which I've not built yet. Because linkable then, because you can link files and execute files. So you can link. I really built the philosophy via the examples. So let me show you the examples too. So the examples of linkable cells are here. Let me just go here. See the examples. See the link LT file format, LT file, and go run main.go dash inputs video.jf. The fan page. FM peg. What are you doing in a holy fucking yeah. Mm. Okay, now let me go now. So the idea of what I'm doing is that. So let me go.